Hi friends, welcome back. Today we are going to solve one important coding interview question. Remove BST keys outside given range. So this is one important coding problem I recently came across, and I just thought that it's worthwhile to create a video and show you guys how to solve these kind of problems. So this is related to a binary search tree coding problem. So we'll go through the example. I'll explain you how we can solve this problem. We'll implement the Java solution in today's session. Before we start looking into the problem details with some examples that I created, I want to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find lots of helpful videos that you can use to prepare well for your coding as well as Java interview rounds. On this channel, you will find out a lot of helpful videos for your interviews related to Java, J2EE, Unix, KSH shell scripting, as well as sequels. So if you are a fresher, junior level developer, you're looking for videos for like coding questions for interviews, as well as frequently asked interview questions related to uh, like Java, J2E coding problems, sequels, Oracle, as well as Unix, then this channel has a lot of good videos available on this channel. You will also find out about 500 different varieties of coding problems solved and explained here with examples and whiteboarding sessions for your easier understanding. All those problems come with Java solution code, where the code is found in the GitHub repository. You will always find out the link to the code in all the video description section, where you can go check out the code, play with the code by creating your own custom input test cases for better understanding of the code. In those solved coding problems, you will find out all important coding questions varieties that are important from coding interview perspective, including BFS, DFS, graph problems, matrix problems, binary search tree problems, coding questions related to linked list, strings optimization problems. A lot of data structure related problems are also there, including stacks, queues, priority queues, hash table, hash map, tree map, hash set, tree set, and many other important data structure related coding problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn more about programming, data structures, algorithms, problem solving, then this channel can definitely help you in your preparation as well as in your coding interview process. So please subscribe to this channel now. Also, whenever we come across any important coding problems or coding challenges, we create videos on this channel to discuss more about the problem, the logic, and the approaches along with the solutions to solve those problems. So make sure you click on the bell notification icon so you won't miss any important upcoming videos here. So let's start with this coding question. Remove BST keys outside given range. Given a binary search tree BST and a range min max, remove all the keys which are outside the given range. The modified tree should also be a BST. So they have given us some examples here. So we'll go through them. Let's go to the task. You don't have to read input or print anything. Your task is to complete the function remove keys, which takes the root node of the BST and the range as input and returns the root of the modified BST after removing the nodes outside the given range. So this is what the problem is asking us to do. The expected time complexity is number of nodes order of, and the auxiliary space is OH, where H is the height of the tree. So now basically if you look at this one example, I also created another example I'll show you in a minute. But if you look at this example, this is the binary search tree that is given to us, right? And they have given us a range minus 10 to 13. So the minimum is minus 10 and maximum is 13. So anything more than 13 should be removed. Anything less than minus 10 also should be removed. So now if you look at this, so minus 13 is should be removed basically because it's less than minus 10, right? So minus 13 should be removed. Then 14 and 15 are more than 13 should also be removed. These nodes should be removed basically. If we remove them, then the resultant tree will look like this after the removal basically, right? So minus 8, as you can see, minus 8 will go here after we remove minus 13, correct? After that, if we remove 14 and 15, then we have to put this 13 here at the place of 14, correct? So 13 will go here and 7 will come here. So after we modify the tree or the binary search tree, we have to the tree will look like this basically, and then it will give us the output like this, minus 8, 6, 7 and 13, correct? So this is what the problem is asking us to do. So the problem statement is pretty clear. So I created one example that we'll discuss more from this example. So here minimum is 4 and maximum is 12. So let us first understand this problem. So uh, if you look at these nodes, then 3 and 1 are basically smaller than 4, right? So we need to remove these nodes basically from this tree, right? So if we want to remove these nodes, then what we need to do, this 6 should go in place of 3. After we remove this, then 6 will go here basically. That this whole smaller, this subtree will be placed here basically. So how will it look like? So if we place it, let's say, then it will look like this, right? 6 will be here, then 4 will be here, and 7 will be here, correct? So after that, if you look on this right side, then maximum is 12, so we have to remove this node which is more than 12, correct? So if we remove it, then on the right side it will look like this, right? 8, 10 and the 13, right? So 13 will be here, correct? So this is how the tree will look like. So this is what the problem is asking us to do. So now you are clear with this, right? What the problem is asking us to do with this example. So how can we solve this problem? When we want to solve these kind of problems where we want to remove something like from these trees actually, right? Remove these nodes from the trees. Then what is the best way? You should start removal from the bottom to up, right? You should go from bottom to up when you want to remove it, right? Because for example, if we want to, let's say, this node, if we want to delete it, we cannot just delete it like this, right? Because the best way is you start deleting from this bottom up, right? Then this will be a lot easier basically, right? If we want to delete it from bottom up. So for this kind of cases, what is the best approach? We should use recursion basically, right? Recursion is the best approach for implementation to solve this kind of problems. So what will we do to recursively solve this problem, right? So I'll just show you quickly. So now what we will do is we'll start with these nodes and we'll go recursively, right? We'll go node by node and we will keep checking if it is outside of this range, right? So for example, when we hit this node, let's say, this is how recursion goes, right? It will goes basically all the way down basically, correct? And here we will keep checking. So is this node outside of the range? Yes, it is outside of the range. Then it means that we have to basically delete this node. So again we will go here. Is this node outside of the range? Yes, we have to delete this node. We have to delete the node 3. So what will we do if when we want to delete the node? We want to check one thing, that is this is out of the range is fine, but is this like smaller than the minimum or more than the maximum? This is one question we have to check, right? So it is smaller than the minimum. If it is smaller than the minimum, correct, if this node is smaller than the minimum, then it means that all the nodes on its left side are also smaller basically than the minimum, right? Because this is a binary search tree. So binary search tree has a very important property. Let's say you have a binary search tree, right? Here you have 2, here you have 20. Always you have all the, if this is a root of the tree, then always your left side will be smaller than the root, all the nodes on the left side, and all the nodes on the right side will be more than this root, correct? So what it means is, if 3 is smaller than the minimum range, then all the left side nodes will be smaller basically than minimum, correct? Then it means that the best way for us is we should replace this 3 with the right side node of the 3, right? So we will create one temporary node for 6, which is the right child of 3, right? 6 is the right child of 3, and what we will do, we will put that node and attach it here basically. That 6 node we will attach it here. Once you attach 6 node here instead of 3, so 8 will point, 8 left child will point to 6. So when you point it to 6, obviously 6 already is associated with 4 and 7 here. So this small subtree will be actually we are attaching here instead of 3. So 3 and 1 will be gone basically, and this 6, 4 and 7 will be attached here as the left child for the 8, right? So this is what we will do. Now when we are going on the right side here, when we reach here, right, when we reach 20, then we know that this is outside of the range. But now we want to know whether it's outside is fine, but is it smaller than the minimum or more than the maximum? It is more than the maximum, right? If it is more than the maximum, then it means that if we have any children on the right side, they will also be more than the maximum, correct? Because everything will be greater than 20 on the right side. Now here it is nothing is there, but I'm just telling you for explanation. So now what should we do in this case? So if we want to delete this node, the best thing for us is we want to just put this 13 in place of 20 here. So we will capture this 13 as a temporary node. We'll take 13 as a temporary node and we will put 13 here. So 13 will go here basically, correct? So once we put 13 here, it will become a right child of 8 actually, right? So sorry, right child of 10. So 8 has a right child 10 and 10's right child we will put as 13, correct? 10's right child we will put it as 13, right? So and in this case automatically 20 will be deleted basically. Once you put a right side pointer of 10 to the 13, automatically 20 is gone basically, right? So this is the way we will remove the BST keys which are outside of the range, right? So now I think more will be clear once you look at the code, but this is what the approach is basically and the logic is to solve this problem, right? And as I said, recursion is the best to implement these kind of problems. And in the recursion also, we will have to actually start going from, means we should start removing nodes from bottom up basically, right? This direction, bottom up, correct? So we'll start removing nodes from the bottom up direction. So let's go to the code, then it will be more clear to you, but this is the general approach. So this is also one of the interview questions got asked in the past interviews. So this is the method remove keys. It's going to return a node which is the root of the binary search tree after removal of the keys, right? So what we are going to get, we are going to get the root of the binary search tree. We are going to get minimum and maximum value, right, as the input. So our base case will be if root is null, we will return null. That is our base case, correct? So after that, what we will do is we will call this remove keys method on the left side of the tree, right? Left side of the root, which is left subtree basically, right? We are calling this method on left subtree and we are assigning root.left is equal to this. Whatever it returns, it will be assigned to the root.left, correct? And we'll again call this same method recursively here on the right side of the root, right? So root.right means on the right side, and we will put assign root.right is equal to whatever is coming from this method. So this is very important. These two sentences are very important here, right? So first, and this is also I put a comment. So first we have to fix left and right subtree. So what this means in another term is we are actually deleting bottom up, right? Because whenever you want to delete something, you want to delete 3, then you have to first go and check if there is something you want to delete here also and on this side also, correct? Always you will keep going as much as you can on the downside basically, right? So that is what it means. So after this one is done, so we have actually done with our left subtree and right subtree of our current node, right? Now we have to also check the current node also, right? The current node might also be out of the range, correct? So this is another very important thing. Now we are done with the left subtree of the node and right subtree of the node, but our current node or current root that we are looking at might also be out of the range that we have to handle, right? So here is that we are handling it. This is the case one where our root means the root of the subtree that we are looking at, it is less than the minimum. Then what we will do, we will take its right child, right, and we will make the root is equal to null and we will return right child. So what it will basically do is this one, right? So it is less than minimum means, for example, 3. If 3 is less than minimum, then we are actually going to make like this 8 dot left will become 6 basically, right? 6 is right child of 3. So that is what we are doing here, right? So right child is, for example, in this case, right child of 3 is 6. So we'll return 6 here, right? So 6 will get returned here, and it will get associated with the caller. So caller is basically 8, right? So 8 dot left will become 6, correct? So 8 here, as you can see, 8 dot left will become 6. So this is what we are doing here, correct? When root value like root dot data is less than minimum, right? So another case is that root dot value or root dot data can be more than maximum also. This is another case, which is case 2. So in that case we have to get the left child, right? So for example 20, right? This one is actually more than maximum, right? So we will have to get the left child of this node, right? And then assign it there, correct? So this is another case actually, right? And then we will return left child, correct? And root we will means we will mark that node as a null basically, right? So the root node that we are looking at, will mark it as a null here, means we are actually kind of removing it, correct? Once this left child gets returned, then it will get associated here or here depending on where it is called from, correct? So after that we will return root here, right? So if we reach here, it means that basically we have to return the root, correct? So this is the recursive implementation, how we can solve this problem. So I hope this is clear to you, but this is how the recursion work. We are first doing it on the left and right subtrees. Why we are doing it on the subtrees first? Because as I said, when we want to remove anything, if we want to remove this, let's say root, then we have to first handle everything below this root, basically on the left side as well as on the right side, and then we will actually handle the root itself, correct? So that is why we have to first do these two things, right? And we'll call this remove keys method. Recursively we'll go to the left side of the current root, we'll go to the right side of the current root, and once we are going it, whatever we get as a return, we have to associate root dot left is equal to that node, right? And root dot right is equal to that node. So basically, since we are doing it this way, our binary, whatever the resultant tree we are going to get is again a binary search tree basically, automatically, right? This will automatically happen because of the way it is implemented. So for example, after removal we'll get like this, which is again a binary search tree, right? So once we handle it, the left subtree and right subtree here, then we are going to handle the root of that subtree itself, because as I said, the root of the subtree itself might be out of range, right? So we have to handle that case also. So there are two possibilities when we say out of range. It can be less than the minimum, which we are handling here, or it can be more than the maximum, which we are handling here. So if it is less than minimum, we have to take the right child of that node and return that right child, and then we'll mark that root as null here, right? If it is greater than maximum, then we are going to take the left child, correct? And then, for example, in this case, it is more like less than the minimum, so we have to put the right child here, basically, right? And in this other case, we have to put the left child, right? And if we reach here, then we have to return the root itself, right? The root of the subtree that we are currently looking at. So that's all actually as the implementation goes. So we'll go and test it out. We'll compile it and run it. So one thing I wanted to show you is I created a custom input here, right? This is the custom input that I created for this same tree that we were discussing here, right? So this is the same tree I created. So after we remove for min and max, min is 4, max is 12, right? Min is 4, sorry, max is 16 here, right? So max is going to be 16, so it's not 12. So in that case, we will be actually removing 20, we'll be removing 1, we'll be removing 3, correct? So let's see the result now. I'll show you the result. So after we remove, the result we are going to get is 4, 6, 7, 8, 10, 13, right? So let me just show you the tree after the removal, right? After the removal, the tree will look like this: 6 here, 4 here, and 7 here, right? And 10 here, and on the right side of 10 13 will be here, right? So now if you look at the result, it is showing 4 6 7 8 10 13, right? 4 6 7 8 10 13. So it is the way the binary search tree will look like, correct, after the removal. So it's passing our test case. As you can say, you can see here, the output we are having and expected is same. We will go and submit this code snippet now. Make sure it passes all other test cases. There are 256 test cases it is running against. So our code got successfully accepted. It passed all the 256 test cases. As you can see it here, it took 5 time to pass all the test cases. So this is the way we can solve the remove BST keys outside the given range using the recursion, right? So we have used recursion to solve this problem, as you can see it here. So make sure you know how recursion works. If you are a junior level Java developer or fresher, make sure you know how this recursion works. Try to implement some recursive solutions by yourself, so you will get familiar how to implement the recursion and how the recursion actually works, right? Because many times there are questions related to recursion in the coding online test as well as in the coding rounds of interviews, right? So this is one of the very important things for the interviews, that you should know how recursion works. If you are new to this channel and if you haven't already checked the important playlist on this channel, I would like to mention that there is a very important playlist on this channel. Its name is Leetcode and Leetcode Solutions. That playlist is very important because it covers lots of frequently asked coding questions which got asked recently many times in the interviews by many big companies. So make sure you go through that playlist. Check out the problems. You are going to learn a lot there, more about problem solving, logic building, data structures, algorithms, how to implement difficult solutions using Java. So make sure you go through that playlist, and you will also be able to cover all important different concepts and different varieties of problems that typically appear in the coding rounds of interviews. You will get a really good preparation there. I'll repeat the name of that playlist. It is called as Leetcode and Leetcode Solutions. Apart from that, if you still are looking for more coding problems for your practice, then there are 3 other playlists available on this channel. The names are Code Forces, CodeChef and AdCoder. All in all, you will get more than 450 different varieties of coding problems solved and explained for your easier understanding. All the problems come with Java solution code. You will find that code in the GitHub repositories. You will get the link to the code in all the video descriptions section. Uh, if you like this video, if you find this video helpful, if you like the way the video is created with this explanation and whiteboarding session and examples, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the goal of this channel is to help people in their coding problem solving and in their interview preparation process by creating videos that are useful for the interview preparation as well as useful in the learning process, where others can learn problem solving, they can learn more computer science concepts and more about programming and Java programming. So if you like this video, give it a like, share it as much as you can with your friends and colleagues, so they can also watch these videos and learn from these videos. If you like the videos on this channel, and if the videos on this channel are helping your learning process, you are learning something new here on this channel, and they are helping your coding interview preparation process as well, then don't forget to mention that into the comments. Write down the comments about these videos and tell us about it, how the videos are helpful to you. Your comments are very valuable to us. That increases our motivation to create more such good quality content, so others can also learn more about problem solving, programming, data structures and algorithms. So if the videos are helpful to you, then write down in the comments. If you want us to create any like videos about any particular topic about computer science, programming and Java programming language, then also write that into the comments as well. Uh, there are a couple of important interview related videos coming soon for the freshers and junior level developers about frequently asked coding questions about SQLs as well as Unix and KSH shell scripting. So make sure you stay tuned, keep checking on this channel about the newly coming videos. There are a lot of interesting videos going to be coming soon here. Keep coding, keep solving different varieties of problems, and keep your learning process continuously going on. And thanks for watching this video.